first want to thank you guys for the invitation, having us come up here to your facility here in Vancouver, British Columbia. This is my first time up here, and I'm enjoying it, so thank you very much.
Thank you for coming. It was really a pleasure to have you here, and thank you for everything you did today.
Yeah, so obviously we know each other here at the table, but for our viewers, if you could, Saeed, just introduce yourself and...
Sure. My name is Saeed Govahi. I'm the Director of Marketing and Branding in pH7.
Yeah, thank you so much, first of all, Rich and Ed, for coming up here. That was an amazing day. And I'm Mohammad Mohammadi, CEO and founder of pH7 Technologies.
Yeah, we had a great day, didn't we?
Yeah, it was amazing.
Amazing day.
Yeah.
We got to go to the pilot plant and see how it's run. It's nice to be able to get your eyeballs on it and actually walk through it and see how everything from start to finish.
And meet the staff.
And meet the staff. Yeah. And we got to meet your lab technicians and your lab manager or the R&D manager for the lab. Very nice gentleman. And other staff members here. So it's been a great day. So we thought we'd just finish off our day with a quick podcast, and maybe you guys can enlighten us. You know, we know what's going on, but we'd like to bring it to our audience and kind of introduce you guys to the audience that obviously don't know who you guys are yet and what your technology is all about. So
Mohammed, the last time we had you on the podcast was at IPMI in the summer session, the full conference.
Yes, that was last year, I believe.
And that was before you came to market. And so we didn't really get the opportunity to speak too much about your company.
Yeah,
so
that's right. Correct.
Here's your opportunity.
Or our partnership, for that matter, right?
Yeah, exactly.
That's true.
Exactly. No, it was amazing. So I believe our staff was really excited as well to see our partners. So thanks for coming up here. And that was an amazing day. So far, so good. So thanks. We had a good visit, the pilot. So you actually see it live in operation. You see we are scaling it up as well.
Larger equipment.
Larger equipment, more throughput. We can process more materials. So yeah, I mean, last year IPMI, we were about to start building a pilot plant. So we weren't actually on. We received some samples from you, some testing, and we started operation of the pilot plant Q4 last year. So in November, December timeline, and processing different type of materials to extract PGM and create a PGM concentrate.
Describe that. What type of materials?
Yeah, so we can extract any materials that's loaded with PGM, coated with PGM, any type of spent catalyst from AutoCAD, diesel, gasoline, power generators, with any type of matrix. So I believe we have done zirconia titania based material, wash coat, silicon carbide, silica alumina, cardiorite. I believe all different type of materials that we have been testing so far, especially some of the materials that you told us it's really a problem in the industry. And I believe we could process it. We shared the results, and I believe you were happy.
Yes, we are happy.
Yeah, okay. Good results.
Yeah, well, what's interesting is the return is based not on a 3 to 5% sample of the bulk material, but it's the actual bulk material that is processed in whole through your reactors, and you extract the precious metal and report on recovery. Recovery is not known in the catalyst industry. Yeah. It's always based on sampling. And so the results are very, very positive for us. What we're seeing, we've brought some other partners to the table. They've brought materials in as well. And now everyone is clamoring for capacity.
Yeah. Yes. No, that's actually, you made a good point on the sampling. So I show you how we actually measure the weight and the mass balance that we do at the pilot plant. In every single step, how we record the PGM extracted, how much is going to the system, how much is coming out. So we have the ability to have the full mass balance for every single lot that we receive. And we do the mass balance in 100% of the sample. Right. Not only 3% of the sample or through the auto sampler, whatever coming in, it goes to the reactor, we leach it, we extract it, we dissolve the PGM, we have a sample of it, and we do the full mass balance of the 100% of the lot, and then we report the grades.
Based on recovery.
Exactly.
And the thing in this industry always has been, how is the sample obtained?
Yeah.
Or the subsample. So there's a whole science around sampling and subsampling to obtain a representative sample of the material when it goes into the laboratory,
Correct.
so that the report coming out of the laboratory is accurate. And mistakes occur in sampling and subsampling. And in this case, those steps are eliminated. And so therefore, those possible mistakes are also eliminated.
Correct.
That's a good point.
It is. So that's just to elaborate on that point. We're all looking for homogeneity. So it has to be a homogeneous sample. So as much as you grind it, just a homogeneous sample, you can take a more representative sample. And I believe we have the most homogeneous and representative sampling method because we take liquid samples. We digest it, leach it, dissolve it. And the liquid is the most homogeneous sample in the world. So you take it, liquid, all PGM is actually in every single spot of that liquid and that solution.
Right.
It's the same.
Right.
So you take it from the top, from the bottom, doesn't matter because it's liquid, it's homogeneous, and it's mixing.
Right.
So, and that's where we take a sample. Then it goes to the lab through the ICP-MS that we have. I believe you saw our ICP-MS
Yes.
in action. So, and that's, I believe, the most representative sampling method.
So what I saw in the lab is you have fire assay capability, you have XRF, you have ICP,
Correct.
and you also have a really interesting machine,
Yeah.
that microwave acid digester.
Yes. So as a QC of our, so we do actually all three of the methods. So we do fire assay, we do microwave acid digestion, and then a sample from our leach from reactor. That we take a sample, liquid sample, going through the ICP-MS. We use all of them for the head sampling, for the tailings, our recovery, our efficiency. We do the mass balance through all of these processes. And we got really good results so far. So comparing to industry, I believe our error is pretty low because we eliminate those error points
Right.
through the process, the sampling, subsampling, as you mentioned, and it has been a challenge not only in this industry, the whole mineral processing industry, the whole mining. The sampling is always a challenge, and through the experience, I learned the best way to sample it is through a slurry, through the solution, which is the most representative sample you can take from
That's right.
any type of process. So that's what we're trying to do. And as a QC, we have the microwave acid digestion as well, which is dissolve everything. 100% of the material will be dissolved. We take a sample, run through ICP, and we will see where the PGM is. And as well as fire assay as a QC. So fire assay is a standard for the whole industry. Everyone is using it. So we use the same method just as a comparison and as a standard, as a QC. If you want to be paid on fire assay sample, yeah, we're more than happy to do that. But we realize that the solution sample is always more representative, that 1% that goes through the fire assay and then ICP-MS. On average, the ICP samples has been always higher than fire assay or XRF. So it has been, based on my experience, more or less on average. Sometimes the other one is higher because the sampling is, you take from the highest grade of the sample. Sometimes it's way lower. Again, it's all because if it's not a homogeneous sample.
Right.
As much as you grind it, 1% of the sample, it can go anywhere.
It could be stratified. There's a lot of different reasons why it's not homogeneous.
Exactly. And especially when you ship it on the road, PGM are heavier, higher density.
There's a little bit of vibration that's occurring.
You know?
There's some classification
Yes,
that's occurring.
right.
that's exactly. So where you take that sample is important as well. So all of these are, I believe, I don't say other methods are not accurate. I would say we try to reduce the error in
Right.
sampling.
Right.
And that's happening through the liquid sampling method that we have, the solution of the sample.
Based on extraction.
Exactly.
So we discussed that in December of 22, you had brought online your phase 1 pilot. You've successfully closed a recent capital raise, and you are in the process of expanding into phase 2 capacities, and looking to see that in operation here in about a month or so, hopefully. And then after that, what are we looking at? What do you guys see? What is your vision here?
So we are trying to expand the process, so increase the capacity, and not only in Canada, we want to go internationally, build these different operation plants with different sizes and capacities,
So
depending on the market demand.
We're in Vancouver today.
Yes, yes. So this pilot plant is in Vancouver. Our next phase of the pilot plant, which is the higher capacity, will be in Vancouver. And our first commercialized plant will be in Vancouver, but with a smaller capacity. And then we will build another larger capacity plant down in the US, in Europe, in Asia. So wherever the demand is there, the materials are there.
Is that going to require an additional capital raise, or are you good?
So we believe we're good, actually. So with the thanks to our investors in this round, amazing investors that we had for this round that we closed.
Yeah,
our Series A.
name some of the investors in your firm.
So this round has been called by Pangea and TDK Ventures, amazing partners, investors. So I'm so happy, so glad that we had them. And then they put together a syndicate, and we got really great investors in the team. So FM Capital, Rhapsody Ventures, BASF Ventures invested in the company as well. We got collaborative funds, Sea Change investors. So really amazing investor group invested in the company, and we are so, I believe, I wouldn't say lucky, we deserve it, but that was a tough market. That was really tough market raising
agree.
money.
Current market is very
you know, but
Invest in market.
I would say, Rich, it's an acknowledgement of the technology that's been developed. And I have a question for you, Mohammed. How did you come up with this idea? As the founder of the company, did you wake up one morning and say, I want to practice solvent metallurgy in this space and closed loop system with a green technology? How did you come to that?
no, that's actually a great question. So nothing happens overnight, you know. Sometimes you have that aha moment that, okay, this is the way you should do it, but you have to think about it before that. So that was always behind my mind, to see how we can solve this wastewater problem. So acid-base chemistry, wet chemistry is, you know, it's always cheaper than pyramids. However, the amount of wastewater that you generate, the acid-base chemistry, contributing the reactions, you consume the acids, at the end you have wastewater that you have to manage it. And it has been for the last 10, 15 years, wherever I had an operation, mineral processing, chemical processes, wastewater management, that was always a problem.
But
That
acid base
wastewater.
also produces off-gas.
Off-gassing, exactly. SOx, NOx emissions, all of this. So the idea of closed-loop system has been always in my mind, and I met amazing people through this journey that helped me to be able to design and implement this closed-loop system. So we applied organic chemistry, inorganic chemistry, and electrochemistry all combined together to be able to design this closed-loop system.
Amazing field.
Yeah, so it's not only one, so we have this solvent. No, it's not only about that solvent. It's about the whole process altogether, and combining these chemistries. So I believe you met our R&D team. There we have PhDs and postdocs focused on extractive chemistry, electrochemistry, inorganic chemistry, organic chemistry. And the idea started with just how to design this, how we can have a solution, a medium that doesn't participate in the reactions. It just hosts the chemical reactions.
Right.
Itself, it's not going to be in the reactions while maximize the solubility of the target metals, PGM in this case. And I started with that, adding electrochemistry, how we can extract it, how we can actually increase the efficiency and design the process. So we started the lab test 2020, built our first prototype 2021, and built our pilot plant 2022. And hopefully we're going to build a commercialized plant 2023.
Yes.
So yeah, fast growing, amazing team. I'm really grateful for that. And really looking forward to the future.
So you've answered several of the questions I wrote down here in
Good.
preparation.
I have one, though. Obviously, we know this, but it's a good question. Why is wet chemistry so important to catalyst recycling?
So that's a great question. I believe this chemistry will enable the catalyst recycling industry to increase the capacity of the recycling. So the materials, low-grade materials, which is other materials which is problematic for pyromet, the wet chemistry could extract it. So I believe we tested, I told you that we tested different type of samples. You're aware of that. We received silicon carbide-based material, high carbon content materials, chloride content materials, zirconia, titania, wash coat, all of these has some elements in there which is make it difficult for the smelters, for the furnaces.
Okay, let's talk about wash coat.
Yeah.
Comes off of an iron substrate which
Yeah.
has a chromium alloy. Chromium is a problem for a pyrometallurgical operation. It attacks the furnace lining, drives up the cost, and more maintenance, which means more downtime. So that's an issue. And I was going to ask you, in your opinion, what are the pinch points or are some of the problems in pyrometallurgy of these low-grade materials?
So yeah, there are. First of all, I believe some of the low grades. So everyone wants high grades, and that makes sense. You have the capacity, limited capacity. You don't want to fill it with low grades.
Right.
Your cost is high, lots of energy consumption. So it's better to process the high grade materials rather than low grade materials. So I believe that's one of the pain points.
Can I stop you for a sec?
Yeah, sure.
From what I understand, from a capacity utilization perspective, that these high-grade smelters are full.
Yeah,
And they don't have capacity
correct.
to process low-grade,
Low-grade, exactly.
in addition to the points you're going to further make here.
Yeah, exactly. So that's one of the problems. So there are lots of low-grade materials that doesn't have any room. Some of substrates for low-grade materials are really problematic as well. So like silicon carbide, high carbon content, which cause lots of problem in pyromet operation furnaces, controlling the temperature. When you have lots
That's a
of
big
carbide
one.
there, it's really big deal
Yeah.
for pyromet, for furnaces, not easy. And
Run away from you.
yeah, zirconia, titanium, higher melting point, really high
Temperature
temperature
is
for
way up.
melting point, it's way up. So these are the main problems we see in the market that we can actually solve that problem with wet chemistry. And because the way we look at it in extraction, we don't want substrate. So in pyromet, you take care of substrate, you melt it down to be able to collect PGM on a collector. We see it as a different solution. We don't care about the substrate. Whatever substrate you have, that's good. We don't care about it because we care about PGM. We attack PGM only.
Right.
So it doesn't matter it's loaded in what kind of substrate because we attack PGM only, we could extract it. It's not a problem for our process.
That's a very good point because pyrometallurgy is attacking the substrate to produce slag for a separation of PGM away from the substrate
Correct.
and then the slag itself onto a collector metal.
Yes.
That's a very good point.
Yeah.
So you don't target the substrate, you
Exactly.
target the PGM.
Just the PGM. Selectively dissolving the PGM into the solution. And that's our target. So that's why we can handle any type of substrate because they don't participate in any of the reaction. We don't need any reaction with substrate. We only look into the oxidizing PGM, solubilize the PGM.
So obviously no carbon limits,
Doesn't matter.
right?
Literally doesn't matter. So no carbon limit, no melting point limit.
So,
It's as long as you can grind it, send it to us.
so the cynic in me is always going to ask a wet chemistry operation, how much aqua regia do you use?
0.
And in case the audience didn't hear that, what is
Zero.
it?
Exactly 0. So we don't use any nitric acid, any hydrochloric acid, any hydrofluoric acid, any of these type of acid. We don't use any of that.
Right.
But our inorganic chemistry is inorganic salts and some diluted inorganic acid to activating the chemistry. But none of these heavy acids is the base. So the base of the chemistry is just water and solvent that doesn't react with any of these acids, and then they host the chemical reaction, the oxidization, the solubilization of they just solubilize the PGM, oxidized PGM into the solvent media, and then we extract it down the road.
So, from a mechanical perspective, how we operate in the auto catalyst industry, so we have the ability for hedging, we have the ability for pooling metals at some of the major refineries, if we wish, or selling. So we have a lot of options that are very standard in this industry that are available through pH7 technologies.
That's correct, yeah. And I believe we can do all of that. So we can hedge the price of the PGM through this partnership, another partnership that we have with the partners in the industry. And selling the metals, just transfer the metals to account pool.
Well, some of our suppliers want to get paid. Some of our suppliers want to receive metal into their pool account.
Exactly, which is, we are open to both options.
That's good. So we discussed a little bit about moving into phase 2 with the capital raise. Congratulations. That's awesome.
Yeah, thank you.
Are you guys at this point, are you looking to hire staff currently here at this facility?
Yes.
You want to speak about the positions that are open now?
Yeah, so we are going through hiring technical team, business team. We have to actually grow. The business and the team has to grow at the same pace at the same time. So lots of hiring happening from managers, managerial roles to technicians and technical team, operators at the plant that we're building. All of this hiring going to happen in the next, I would say, 2 or 3 months, hopefully. So lots of hiring, yeah.
Yeah, it's already
Excellent.
started, and we have 3 new members in the lab and in the pilot plant. And we have, I think, in general, about 12 more people that we are going to hire in next while.
Excellent.
Yeah.
That's exciting.
Yeah, looking
We're
for talents.
excited.
Yeah.
Well, I look at what you have envisioned and how you've progressed from an idea to a pilot operation to a capital raise, moving towards phase 2 pilot, and then construction of production facilities. And I have to say that, the concept, for me personally, is very interesting and very rewarding for me to understand and just chew on the different aspects of what is being accomplished, because that's deep in my heart and my nature is process technologies in the precious metal recovery, secondary recycling, secondary metals processing sector, and I'm really I'm amazed at your progress, and I'm very humbled and proud of what you guys are doing and what you've accomplished, Mohammed. This is just amazing.
Yeah, thank you.
I'm just so happy to see your success.
Yeah, it's great. Thank you. Nope, it's actually, it means a lot coming from you because you have an engineering background, metallurgical background, mineral processing, precious metal, gold, PGM. So it means a lot. And you saw our pilot plants, I believe.
Yeah. You said you're hiring.
Yeah, it's thanks so much. It means a lot. So I believe you liked it. Yeah.
I do.
Yeah.
I do.
Good.
I'm excited.
Happy to hear.
I'm looking forward to coming back.
Yeah.
Yeah, we'll be coming back in the future, and we're also looking forward to seeing how the company progresses and grows, and how the staff is going to expand, and the marketplace is already excited and responding in a big way right now.
That's right. I was just going to say the scaling and this fast-paced growth that is happening is many of them is market-driven. Mm-hmm. The demand is there, the potential for way more demand is there, and the market is hungry for this. And we are really grateful to have so much support and see a lot of people that they are eager to know and eager to join us in this journey because they see it is a good solution. It's something that is really haven't been there before. It's revolutionizing a process that has been there for years, and now they see how it can be better. That's easily is getting us to work harder, to move faster, and to grow bigger, in order to address the demand that we are seeing in the market.
That's a good point. That's a motivation, actually. When you see there is a demand, you actually call me. We're going to increase your capacity. We need more capacity, more capacity. That's good. That's that's a motivation that we have. Good response from the market, and really grateful for the partners that we have. So,
well, speaking with your staff today, we are, noticing that people are excited, and they're saying that it's a wonderful culture to work here, and they enjoy working as a team, accomplishing goals, and then celebrating together. So I like that as well, and that's really what's needed is a culture of, or an environment that spurs this future growth and success. So what do you see in the future? What does the future hold for pH7 Technologies? I think I heard a few conversations earlier today about some other expansion areas outside of the AutoCat or diesel recycling of PGMs.
Yeah, that's so with this process, with this design that we have, we can go to other markets as well, processing other materials, targeting other metals. So our goal is to target the critical metals, which is vital for energy transition, electrification, such as copper, tin, nickel, cobalt, these even base metals. And when we accomplish PGM roadmap that we have in our mind, commercializing this process, we already started R&Ds for other metals such as copper. We are really advanced in the copper, actually, and other type of recycling from, you say, electronic waste recycling, for example, extracting base metals, which no one actually look at it that way. So everyone is focused on gold because there are some gold in there, but I believe base metal is more important. There are some tin in there, there's some copper in there, there's some nickel in there. If you could recycle that, the gold is going to come out.
The gold will come with it.
Exactly. So,
Yeah, exactly.
Well, especially with your process, your wet chemistry process.
exactly. So this is how we look at it, and going to the mining as well. So providing solution for mining, concentrates, ores, and tailings, with a focus on copper. So the future is we're going to have a focus on copper extraction from sulfide ores, sulfide concentrates, secondary, primary, which is a pain point in the market. Moving forward, 80% of the copper will come from sulfide ores. So oxide ore is depleted because it's already been extracted. So it's going to be through the sulfide resources, which is lower grade, more problem, and concentration, shipping overseas, smelting, all of these problems in the market. So that's another market that we are targeting.
No more in situ leaching of copper with sulfuric acid.
Exactly. It's not going to happen.
That's not environmentally friendly.
Yeah, true. And it's not going to happen because there is no more oxide
Ores that are available
Exactly.
on the surface
Exactly.
for that leaching.
Exactly. It's mostly, I believe I read a report last week. So Masoud put together a market research on the copper, and he found actually amazing reference on the copper sulfide that in the future, 90% of the copper come from sulfide because oxide is going to be done. It's not more, it's already extracted for the last 50, 60, 100 years. It's on the surface, exactly.
It's on the surface of the Earth's crust.
That's it.
That's what, it's in the oxidized zone of the Earth's crust.
Yes. So yeah, these are the projects we are working on it, but main focus, commercialization of the PGM. And in the future, we will see copper, tin, other base metals extraction through this process as well.
That's exciting.
Yeah.
That's good stuff.
Thank you.
You mentioned earlier the term, the world's first green refinery.
Yes.
I had never heard that before.
Well, all the methodology that we are using, all the advantages of this innovative solutions, this closed loop is creating, is actually ending up, is resulting in a very green metal refinery. We can extract, as Mohammed was explaining, the PGM or critical metals, doesn't matter what, we can apply this methodology to any kind of extraction in right now and in the future with the big reduction or on environmental impact, reducing the water waste to almost zero, bringing the CO2 emission to very close to net zero. So what can be greener than this? This is what we call it, the green. We can proudly announce that we are the first green refinery in this industry.
Yeah, that's, we've been talking a lot about, off-gassing and water treatment of acid solutions and high energy inputs that are eliminated with this process. Can you describe what the competitive advantage is over traditional pyrometallurgy? And when I say competitive advantage, I'm thinking dollars and cents.
Yeah, it's clear. We have a lot of environmental impact that it is like huge competitive advantage. But if you want to talk to dollar, we increase the production of the PGM. Actually, with this methodology, it is way more financially sustainable method. Therefore, creating more, extract more PGM from the recycled material.
I think if we could maybe put it succinctly, we might say that there are low-grade substrates that don't fit the flow sheet of pyrometallurgical operations.
That's right.
That are just languishing, and those metals are unavailable because they're not being recycled to the closing the loop on the circular economy.
Exactly.
It doesn't close the loop. It gets manufactured, it gets used, it goes into storage, and that's where it stays.
That's
Exactly.
right.
Exactly. Right now, these materials are not coming back to the market. Those PGM, they already used, spent, but no one recycle it because the recycling actually capacity, they don't want to have their, for example, milling capacity, decanning capacity, focus on those materials because they don't have any room. So even collectors don't go after them. So with this process, I believe we could extract those materials in an economical way, which is economical for us and for our suppliers. And we can increase the recycling market by extracting these PGMs and close that circular economy, as you mentioned.
Well, I know that your current activities do not include decanning, do not include crushing or milling. Do you see that in your future at all?
Definitely, we are open to it because if we see that's a bottleneck, we do grinding.
Right.
If we see decanning is a bottleneck, we do decanning. So we are not afraid of that. We'd like to increase the capacity, help our suppliers. Whenever we see they need help, we're going to be there. So,
Well, we did the same thing.
Yeah.
When you brought the technology to pilot and you needed materials, we looked at what our facility had and said, we need to increase our grinding capacity so that we could help launch this project.
Exactly.
And then we had some other partners come to the table that had grinding capacity that shipped materials in. And we've got you through phase one, and now everybody is clamoring for, where's additional capacity? We've got materials here we need to get shipped.
That's when Mohammed looks at his phone and says, it's Rich again.
That's Richie.
No,
Leave me alone.
when can I send more volume?
No, it's actually it's not a really hard job for us to do the grinding capacity. We need more room, we need more facility, just more square
bigger
feet
footprint.
exactly. So, which is not a really challenge for us,
Or a major financial commitment either.
No, it's actually it's not that expensive. So it's really cheap. We can do the grinding. And if we see the market needs grinding capacity from our side, we're open to it, definitely. And I believe with commercialized plant, we're going to have that grinding capacity. So to be able to bring more materials. But another competitive advantage I believe we didn't talk about is energy consumption.
Very good.
That's one of the
That's a good point.
major points, I believe, for everyone. Not only for suppliers, not only for us.
I think energy is going to get tight in the future.
Exactly. And our energy consumption is really negligible comparing to pyromet. It's way lower because
If you put it up on a graph or something, but what would it be? Maybe 5-10% of what a pyro operation
That's
consumes.
exactly it is. It is.
That's how I envision
It
it.
is exactly.
It's
So
expensive to have those furnaces running
Yeah.
24/7.
yeah,
That's why they prefer high grade, because there's a margin
They have to
to
have
overcome
high
the high energy cost.
correct.
Actually, we are studying to have the solar energy for our
Yes.
commercial plant.
So
That's
and
how low the energy consumption is.
That's great.
And we are putting it in the study to see if it is possible, and it looks like we can achieve it.
Mm-hmm.
And then that's what we are doing.
yeah, it's possible to provide the full energy requirement of the plant with just solar panels on the roof.
Mm-hmm.
That's how energy efficient this process
That's incredible.
Yeah,
That is
it's-
incredible.
It's pretty low
yeah, it's really low energy
cost,
consumption.
low
So, exactly.
energy consumption.
So our main energy consumption is just heating the materials up to 80, 90 degrees centigrade, and that's it.
That's it.
That's it. That's all energy that we need. The pumping, everything is easy, just through the air pump.
And
just yeah.
and half of that energy input is just to warm the facility for the workers.
Yes.
I noticed that today. I said, "Gee, this is just for the environment for the worker, and it's
Yeah.
half the energy that goes into the process."
Right.
Another thing I'd like to mention with your process, if it's in the material, you're able to recover platinum, palladium, and rhodium, correct?
Yes. Yes.
So,
So what you're saying,
That's good
Rich,
to
is
know.
the minimum deductions are lower.
yeah, it's 350 parts per million and up. That's the minimum, 350.
No, but that's total.
That's total.
Total.
Total of the
So as an
PG, but-
example,
yeah.
if you have 400 ppm of platinum and palladium, but you've got 60 parts per million of rhodium, the rhodium is still payable.
Yeah.
Correct. That's true. Yeah, so the payment, the minimum payment of the metals, I believe we are the lowest in the market. We could be the lowest in the market because we can extract it.
Right.
And it's our minimum limit. We are still working on it on the commercialization, and so I don't want to put a number in here.
No,
but
I realize that.
we're gonna be way lower than
The point
the
is,
current market.
if it's there, you're able
we can
to
extract it.
extract it.
Exactly.
You can recover it.
Exactly.
Well, pilot plant terms have been extended. I realize that there's some serious work being done behind the scenes to determine the efficiencies of scale and what the next series of terms will be extended to the marketplace for phase 2. But then again, we're also going to be looking in about a year or so, maybe a year and a half, full production capability. And then again, we may be looking at new terms in the future.
That's
Correct.
So we don't want to speak to terms today, but they're being worked on and being analyzed, and they're becoming more favorable, is my understanding.
Yeah.
That's right.
So we have volume, then better terms for the volume. higher
That's
volume.
right.
Yes.
That's right. So, yeah, when are you coming to Southern California? You're going to set up in the Temecula Valley where we're at?
If you give us a land, yeah, we will be there. No, definitely. This is a plan. So we're going to be in Canada. We're going to come to the US as well. We go everywhere. So this is the plan. We're going to go internationally.
We're
That's
going to
great.
strategically looking into the consumer market. So we're going to have one in Canada for this territory, and then we're going to open another one in US, which has bigger capacity, and that would be for another territory. And look into as I said, based on market demand and what the market-driven is, a more market-driven scaling strategy that we see where are the potentials, and we got to start right away there.
Well, this is April of 23, and I understand you're presenting at the June conference for the IPMI this year. That's exciting.
Yeah.
You're going to get up there. You're going to talk
Yeah.
about all of this.
Yes.
Yeah, definitely. We're going to talk about technology,
Looking
about
forward
the
to that.
solution we bring into the market,
Yeah.
and looking for more partners, suppliers.
Mm-hmm.
And yeah, I believe it will be exciting. already excited about it.
Absolutely.
So looking forward to
Yeah.
it because it's going to be very exciting. We have like five member of our team over there, and Mohammed is presenting for the first time, opening to everybody what the technology is about, and this is really like a benchmark that we are doing it. This is one of the benchmarks of the company that we're starting from there.
That's great. He'll do great.
Yeah, I believe by
he's
that
very
time-
passionate about it.
Yeah, I believe by that time we should have the new capacity as well. The new phase 2 of the pilot plant will be operational, so higher capacity. It's going to be exciting. Yeah.
So I have to ask. So what is your relationship with Noble6?
That's good. That's a good question. So Noble6 has been our partner from, I believe we have been in touch for the last 2 years. We started this discussion. We are building this. We are doing this. You sent us some sample. We tested it. And Noble6 is, I believe, not only our supplier, they are our marketing arm, bringing our supply. And I'm really happy with this partnership. It has been working great so far and looking forward to continue this partnership and scale it up.
Well, I want to thank you also for asking me about a year ago to join your advisory board. That was a great opportunity for us to get closer together.
Yeah.
And so we've had an opportunity, besides working as a supplier, as a marketing arm, but also to help inform the board of directors of pH7 of how we understand this industry that we're engaged in, and how we can help. Because I know you're thinking of a production plant, maybe not up in Vancouver, maybe down in the lower 48, and we're having those conversations about that, and we'll see where that goes.
Yeah.
But anything that we can help with, we're here.
No, I believe that's a good point. Actually, we really use your advice because you're coming from technical background and business background at the same time. So you're an engineer, have been done lots of hands-on job in engineering.
Too much. Too much.
And then now business really well, have been in this industry for the last 20 years, 25 years. And I believe we benefited from your advice and so happy about this relationship.
We'll see where the growth occurs, and
Yeah.
we're looking forward to it.
Yeah.
Yeah, we're excited.
Same
Yeah.
here.
Same here.
Same here. Exactly.
Well, thank you, gentlemen, for inviting us to come and visit and meet all of your staff and tour your facilities and get together on this podcast. This is great. We've been looking forward to this for a while.
Yeah.
Yeah, same here. Thank you so much for coming. That was great. So all the team is actually excited about this new phase and growth of the company, and we're really looking forward to it.
Yeah.
Good. Well,
think
thank
it
you,
was
gentlemen, for your hospitality. Thank you to the PH7 staff.
Thank
It
you.
was a great day.
Yeah,
Thank you
it was
so
great.
much for coming.
Thank you.
It was really a pleasure working and being with you today.
Thank you.
Thank
Thank
Yeah,
you.
Thanks.
Thank you. Back.